All right, 2 trains
Oh,
are
not
scheduled.
this question.
Whatever. 2 trains are scheduled to leave Chicago on parallel tracks. The first train will leave at 12 noon, traveling east toward New York City, a distance of 850 miles at 50 miles per hour.
It's like a Sunday drive pace.
Yeah.
Yeah.
The second train will leave for New York City at 1 p.m., traveling at 55 miles per hour. Write a set of parametric equations for each train. So, train number 1.
We could call it T1.
We could, but that might confuse us with our other
Okay,
keys.
all right.
Okay, so what happens here is we are only concerned about the horizontal situation, like they're talking about
Right.
parallel tracks. So
Right.
we're going to end up with 2 lines that are going horizontally
At the same time.
at the same time.
Maybe.
So for Y1, we just need to pick a value, any value, so that it's just going to go along at a certain Y value. And so I'm
Right.
going to pick 2 because I just think that's a cool number to pick.
It's not, yeah.
It's a good one to pick.
Right.
The X is going to have to do with our speed. So 50 miles per hour means that we would be traveling at 50 T,
50,
right?
yeah. 50 T.
50
yeah.
T.
Because T would be, in this case, time.
Right. And so then train 2,
So they're going just a little bit faster. They're like the young Sunday driver. They're a little quicker than
little
Grandpa
quicker.
Sunday driving.
and so for this one, for my Y value, I'm going to pick something like 4. And then whenever I graph it, we'll be able to see them
Right. And if you're
separately.
doing it simultaneously, you can watch them go at the exact
it'll
same
actually
time.
look like a little race.
Yeah,
It's
a
really
little,
neat.
Yeah, a little race.
So my X2, I'm going 55 miles per hour, but I'm also leaving later. I'm leaving an
Right.
hour later. So how do
So-
we put that in there?
Gee, could we say like, has it got to be T-1, right? I don't
Right,
know.
and so-
because it's not at the same time. The other one is already an hour in, so we're an hour behind.
Okay, so should we just do we just do -1?
Maybe in parentheses.
Maybe in
there? Maybe in
parentheses?
parentheses.
Because we're saying the time itself has to be subtracted
Yeah.
by 1?
Yeah. Because this guy doesn't actually get started until the second hour of the other train.
Right. Which would be 55T minus 55. So we would plug, and so how about, let's talk about windows. So for our X's,
Okay.
we would want 0 to, how far is it to New York City?
850 miles.
850.
You know, and on your step on that,
Your scale,
your scale, you
Maybe
probably
like
want
50?
like 50s.
yeah. And then for Y, we just need to be able to see 2 and 4, so I would go
Just
something like 0 to
5.
6.
Yeah, 5 or 6. Yeah, perfect.
Something
And
that you can really clearly see.
scale on that one can be 1.
Yeah, and then for our T's, we know that we're starting at time 0,
Right.
and then we would basically kind of approximate like how long do we think it's going to take, and so I think it's going to take under 10 hours for both of
Oh,
them.
I was gonna say like 500 hours.
That would probably be a lot.
Okay.
So
Okay, so let's try 10 and see
So
what we
let's
get.
try 10.
Okay.
Fortunately, there's this formula that we use, D equals RT, that we could actually figure out.
And we can always change the T if we need to.
We could. So our T step, we could use we can try 0.01 and see how long that takes us. So I'm going to plug this in over here and we're probably plugging it in right now.
Yeah, we're
on the
showing you what's
side.
going on because
All
we're
right.
cool like that.
So 50 T.
These rockets are amazing.
Are the rockets still going?
Rockets are still going. You know, they go up, they come down. Some of them come down with a little bit more excitement than others.
Yeah, that's true. Definitely true.
So,
So you want to talk about what's happening on maybe A?
so on train A is just traveling around.
No, not train A, on part A.
Oh, how long until the second train overtakes the first train? Well, basically, what we have to do is we have to figure out when do those two guys cover the exact same distance. And if we're trying to figure out the exact same distance, that's the X value for both of those, right?
Right.
Right. So if we want to know if we want to know the instant when the second train catches the first, we could just set the X values equal to each other.
Okay.
Solve it for T.
All right.
How does that sound?
Let's try it.
Okay.
So The t equals 0.01, I'm noticing is a little slow, and it didn't go all the way. So maybe we need to pick a different, maybe we need a bigger than 10,
Well,
maybe like 20.
50 times 10 is 500. And
Oh.
we've got to get to 850. So what if we did 20?
Okay, I'm going to change it to 20. I'm also going to change it to 0.05 and see how that helps, if that helps. That's quite a bit faster.
That's quite a bit quicker.
All right, so we're setting our x values, our x equations equal to each other because we want to know when will their coordinates be the same.
Yeah, their x coordinate, as it were.
So I guess I can do that.
Use the second
distributed.
equation there. Yeah.
Sorry. So we want to get the t's together and the numbers on the other side. So that's going to end up being 55 equals 5t, because I'm going to subtract 50t over and add 55. So then I divide by 5 on each side, and that gives me t equals 11.
So 11 hours into the trip,
Right.
train 1 will catch train 2.
Right, and if you have this on your calculator, you could actually go to t equals 11.
Just hit the trace button, or you
then-
could just hit x type in 11 on sometimes.
And if you switch between the two graphs, you should see that at t equals 11,
Wow,
they are
they go
both at
they're
550.
identical.
Yeah, so at 11 hours. And so then it asks how far are they from Chicago, which is where they left. So that's why it's...
that means you traveled for 11 hours.
And the first train was at 50 miles per hour, so
Right.
50 times 11, that's 550
Well, how did you
miles.
know that? Did you do that in your head?
Yeah, totally.
You're brilliant.
How long will it take for each train to reach New York City? Well, the first train would take 850 divided by 50.
Because it's got to go that far.
Right, you've got that distance
I got
over
that
that.
right here. 17 hours.
17 hours.
17 glorious hours.
Okay, and then the other one is 850 divided by 55.
15.45 hours.
And so, and that's just from the time it leaves.
Shouldn't
It'll
that be
take it
850 plus 55 divided by 55?
Why would it be 850 plus 55? Well, like our what?
Oh no, never mind. I'm good.
Okay. So we're just saying from the time that the second train actually
Right,
starts,
right,
it'll take
right.
almost 15 and a half hours. How much would the train have to increase its speed so that it would arrive in New York City before the second train? Now we can basically do like a guess and check kind of thing on our calculator where we go in and we into the y values, and on the first train we can change it like to 51 and then see if that makes it, and just watch it and see if that makes the first train get there faster. So I'm looking at it.
Oh,
no,
it's really close,
really
but not
close. So
quite.
I'm going to change it to 52. So first train, still in the lead.
52 is close, but
52
not
is close,
but it's not
really,
quite.
we'd probably do like 3 miles per hour just to be sure. So increase by 3 miles per hour.
And there's a bunch of really super fancy math we could do to do that. But
Yeah.
you know what? We've got a calculator that we can use for a very good estimation. Why not use it?
Why not?
I agree.